So in this example, we're being asked to calculate our equilibrium constant. We're given some initial conditions of the system that was established, but we're also given information to determine the concentration of some of our entities at equilibrium. Now, just like before, when we had our previous example, the first thing we do is we want to write out our balanced equation so that we can use it to record our information. Now, to record our information, what we're going to do is we're going to use something called an ICE table. And an ICE table is something that will tell us our initial equilibrium, our change in concentration to reach equilibrium, as well as our equilibrium concentration. So once we have our ICE table acronym written down, we can now start recording our given information in it. So first we'll record our initial concentrations. Now for our change line, we don't know how much of our reactants are being consumed. But we do know that for each mole of oxygen that reacts, 2 moles of nitrogen monoxide will react. And this will allow us to produce 2 moles of nitrogen dioxide. So therefore, what we'll do is we'll indicate our changes by calling the change in oxygen X and the change in nitrogen monoxide 2X and nitrogen dioxide 2X. Now, once we know our change, we can get our equilibrium concentration because it'll be our initial plus our change. And so all we do is add the I line with the C line to get our equilibrium concentrations. Once these are known, we can then take them and use our other information to determine our value of X. Because in this case, we're told what our equilibrium concentration of our nitrogen dioxide will be. And so we can therefore take this value and substitute it into the E line for the concentration of nitrogen dioxide. This allows us to determine the value of X. We can then use this value of X to determine the equilibrium concentrations of our other 2 entities. So we can substitute in for nitrogen monoxide, and then we can also substitute it in for the concentration of oxygen. Okay, once we know our equilibrium concentrations, we can write our equilibrium expression. Remember, it's the concentration of our products, raise their coefficient over the reactants to their coefficient. And then we can then substitute the equilibrium concentrations of each of our entities into our expression and solve for the equilibrium constant in this case.